Hi everyone, my name is Nima and this will be my proposal for the research project GASLLM, and this is a generation-aware confidence estimation method for large language models. So this talk will start with motivation and challenges, and then I will introduce some related works, and then finally our method. So for the motivation, when you want to apply machine learning methods in real life, you don't only care about what the answer is, you also want to have some idea of how confident you can be in that answer. And this is especially important in domains like medicine and law, where the cost of being wrong is very high. And so being able to confidently pass off tasks to an AI in these domains would free up these people's time to do the things that matter more. And specifically for medical diagnosis, you may actually have better healthcare outcomes if you were to pass off that task to an AI. And this is because there was a recent work from Google that showed that their medical diagnosis system was actually more accurate at diagnosis than clinicians were. So the primary thing that keeps us from using them in high stakes domains is their tendency to hallucinate and very confidently state things that are actually wrong. And to make this problem worse, post-training frameworks actually make hallucinations more prevalent by pushing the model towards an always answer behavior instead of just being an honest communicator. And so this here is the core issue. The model will produce a response and we don't actually know how likely that is to be true. And so the system that we want to create is a system where we generate responses, but we also have some insight into how likely that response is to being correct. And that brings us to our formal problem statement, and that is that we want to find an accurate way to estimate the probability that a specific generated answer is correct. And the assumptions that we have to make are pretty common in this domain, and it's that our method only applies to queries that have ground truth answers. And so these here are some related works that help guide our methodology. Some preliminary work from Mohammadi et al. Showed that just prompt engineering would not be sufficient in making models communicate their uncertainty. And so this let us know that the naive solution of just prompting them would not be enough for our use. Then some work from iClear 2024 tried to aggregate the token probabilities to estimate uncertainty of responses. And the main drawback of their method is that token probabilities are not actually strong proxies for factual correctness, and in their defense, that's not what their paper tried to use them for either. Instead, their paper used that uncertainty just to determine if a stronger model should handle the query instead, and they weren't using that to produce a confidence estimate for the user. Then some work from EMNLP 2024 tried training a CNN and a transformer on the internal states across every layer of an LLM after it had processed just the query, and they used that information to try to produce a confidence estimate. And they did have quite strong results compared to their baselines, and there are two main drawbacks here. Number one, training a CNN or a transformer requires a large amount of data that may not be available in any given domain. And the second drawback is they only considered the query, where even if the query seems answerable, the model still may hallucinate. And so these last two works are most similar to what I will propose, and they train a lightweight MLP on the internal states, and similar to the above, they only consider the query and not the actual generated answer. So this here is an overview of the method that we're proposing. So what we're going to do is we're going to take a query and then pass it through the LLM to generate an answer, and then manually append a new special conf token to the end. Then we'll have the LLM calculate the hidden states for the whole response, including that new conf token. Then we'll pass the hidden states of a few positions through an MLP to produce the confidence estimate. The hidden states that we'll pass through will be from the last token of the query, the last token of the answer, and the new conf token that we just added in. Then we'll experiment with a few different subsets of these positions to see which gets us the best results. And in this domain, the standard metric used to compare is the expected calibration error, which is basically the distance between the confidence estimate and the actual accuracy. And so by doing this research, we hope to answer two questions. The first is to determine if you'll get better expected calibration error by making confidence estimates off the query and the answer versus just off the query alone. And intuitively, you would think that the query and the answer is better, but including the LLM responses does add a lot of noise, which may lower the overall performance. And then number two will be determining if adding this new conf token to the vocabulary actually helps with confidence estimation.